Some? Okay. So I tried to, I thought about kind of the diverse audience that we've got going here tonight. And I was also thinking about some things that I have going on at work when I put this together, right? So this is really meant to be a little bit interactive, but I'm trying to poke at you a little bit to get you to think about how you use things or don't use things, right? Because we all fall into habits, we all have preferences, things that we think aren't very good, things that we think work really good. And every once in a while we have to back up and reassess that, even if it lands us in the same place, right? That happens sometimes, right? But it's part of growing up is you have to reassess what your own rule set is, what your own goals are. And I think the same is true of technology. So I'm a SQL Server guy, there's no doubt about that, but if they stop making SQL Server tomorrow, I would be an Oracle guy or a MySQL guy or whatever. I'm a data guy, right? I use a relational platform as my primary tool, but I have really nothing against NoSQL, right? But I do have opinions about when that should be used and what it means for everybody. So we're going to try to poke into that tonight because I feel like, especially on the developer side, there's a terrible temptation to use the new and greatest thing. And maybe on the other side, maybe I have a terrible temptation to never try anything new, right? There's a spectrum there, right? But I think, you have to build that philosophy about when is it okay to add something new to your enterprise and to your personal skill set, because you can only maintain so many skills, right? So you have to be deliberate about both of those when you think about kind of cost and time and everything else. So I want to start by going all the way back to 2005. How many of you happen to go back to 2005? Anybody use SQL Server 2005? So that was a big release, right? If you think about the history before that, 1998, SQL Server 7 came out, and that was really the first modernization of the Sybase platform, right? It had some nice changes in there. We went from a 2K page to an 8K page, which made a lot of difference on I/O. And at the time, it was branded as, there's not a lot of knobs as a strength, which really is not so much a strength. But in 2005, they added the CLR integration. They added a bunch of stuff, and it's really where it came of age. And it's when Enterprise Studio, the old Enterprise Manager went away, and we moved to Management Studio, which is not without its own flaws, but there's a lot of change in 2005. So if you think about how you built applications back in 2005 and how we built servers, right, they were all physical. If you were virtualizing something in 2005, it was a local server, something that you were messing with. It was your workstation, it was some web server. It wasn't a DB server because the DB needed every bit of resources it could get to function, because essentially we were running underpowered in almost all cases, right? So it's very much a physical world, which meant that you didn't build servers very often. You spent a lot of money on them, right? You had somebody to manage them. If you look back then, memory and disk I/O were almost always the constraints. You could buy CPUs. They were expensive, but you could get them. But the memory was hard to come by, and certainly the disk performance was hard. And so back then, if you were a DBA, you learned a lot about how a SAN worked, even though you had really no interest in being the SAN guy. Because without I/O, you just can't make it work, right? You just can't get the performance. So when we built databases in 2005, especially in SQL Server, we built them against a relational model because the engine is designed to work with that relational model, right? If you think about why we say we want like narrow tables, narrow columns, it's because we're trying to get as many rows as we can onto an 8K page, because when we do go to disk, we want to get as much as we can at a time. So while it's easy to say, even back in 2005, that disk space is cheap, it's not that cheap when you think about the effort to go get it off disk, load it into memory, maintain multiple copies, all that. So building to the relational design and the SQL engine are very much aligned, right, to work together. And if you try to build something that doesn't really match the relational engine, it's still a very interesting data store, but you won't get the good stuff from it, right? So in 2005, we on the DB side, I'd say most of the developers, were interested in relational design, right? Good, not denormalized work. The core platform back then, and I'll say platform a lot tonight because I want you to think about what that means to you, was fairly full featured. We had various triggers, stored procedures, we had views, we had almost everything you could look for in a modern database, except maybe a great availability story. You could cluster, you could do replication, you could do log shipping, but if you really wanted to protect your data down to within a couple seconds, we didn't really have a good answer for that without going to a third party, right? So you guys remember back in 2005 how that worked? Building, maybe writing a stored procedure, maybe deciding not to write a stored procedure. A lot of times the database was the constraint, but in 2005, the database was really that protected castle, right? It was kind of this really special beast that kind of sat in the middle. And we needed a DBA to manage it, which isn't to say that you always had a DBA, right? Because it's one of the last things you hire, right? Because we're overhead, right up there with QA, right? When you're getting started, you just can't afford to staff somebody, when you're just growing. But you really needed a DBA to manage it because it's complicated. So, good evening. So let's jump forward 10 years to 2015 and think about how the world changed around SQL Server and maybe a little bit about data management. So in those years in between, we had 2008, 2008 R2, 2012, and 2014 released. We're on basically a 2-year release cycle. That's interesting because it's a lot of change, and it means we grew to expect to want to evolve our platform, right? We're getting changes about every 2 years, which can really seem overwhelming. But we learned a big lesson. When we went from 2000 to 2005, that was a huge amount of change, and people couldn't absorb it all. They were frustrated by it. So the SQL team went to a much smaller release cycle. So I thought about putting all the features up here, but it would be a really long list. Because a lot of them are incremental, not very exciting, but some of them are really huge, right? If you think about availability groups, I talk about the weakness in 2005, not having a good story. Availability groups fix that, right? In most cases, if you're running an availability group, you have a copy that has absolutely every transaction down to the time it's committed, right? So if you were to physically lose one of those nodes, you have everything down to basically that point in time. For most enterprises, that's huge because it means you can patch effectively. You can roll over to a different node, patch, and roll back. But we also got in-memory, the hackathon stuff, which if you're in a super high transaction environment is a big deal. We got column store. So if you're not dealing with maybe the prototypical relational data, or maybe you just have a lot, as in billions of rows, column store is really interesting, right? So some of you may have used some of that stuff, but I bet a lot of you in 2015 are still building against SQL Server, just like you were against it in 2005, right? And on the infrastructure side, certainly not, maybe the Azure guys know more about the infrastructure side, but if you're on the dev side, you look at that stuff and go, yeah, what does that mean to me? But you think about all the things that happened underneath, where we added functions and functionality, right? And you don't go out there looking for that. How do you find out about that? So you're probably still largely building like you did in 2005. In 2015, clustering is still hard, right? It's still, a little bit of magic sauce. It's easier than it was in 2000, easier than it was in 2005, but it's still, you really need a Windows guy to build a cluster because you're betting on that cluster being available. SANs are still a thing in 2005. In truth, if you go to most enterprises today, they still have a SAN and they still have a SAN team. But even in 2015, I would say even me shops still had some SAN, or were looking at a SAN because they needed the disk I/O, and SSDs were still pretty expensive, right? We hadn't really fully made that conversion. But on the DB side, at the same time, I would say that while in 2005 you couldn't arm twist a DBA into putting SQL Server on a VM, in 2015 I think everybody was ready to do that, right? Huge improvement for us because it means when new hardware comes in, we could just move the VM, right? And when I say we could, what I really mean is somebody on the VMware team could, right? We tried out this stuff, but that was a big advantage. So instead of having to really rebuild the server when we just needed more power, we could just move it, right? And that was interesting because if you look at the waste from a CIO level, the SQL guys are the ones that waste the most stuff because we're going to over provision, right? We're going to build a server that can handle the peak load that happens Monday at 9 a.m. even though the rest of the week we're not going to need it, right? So VMware gave us a chance to go, maybe I don't really need 48 cores. Maybe I can go with 24. But if I see that that's not working, I can change that, right? That was a big constraint. Imagine somebody going to you to go, hey, it's our once every 5 year, we're going to buy a server. What do you need? You only get one shot at this, right? So you better plan for what you're going to need for the next 5 years. It's very hard to be brave enough to lowball that, right? And so, and DBAs, I guess, are not brave. They're certainly conservative, and so they would say, no, I need a bigger machine, right? I need max power. We would optimize. We would ask for the max on everything. It was kind of a joke with Dell. If you ordered a server for them, they would just max it out because people would try to, well, I'll take that only if you up the cache, only if you do this, right? So they would just, when you got a quote, it would be for everything maxed out, so you couldn't play that game with them. Relational design was still king, I think, but there definitely been a big swarm about Hadoop. Everybody remember Hadoop? It was a thing for a while, and big data certainly still is, but also NoSQL, right? And I think NoSQL came along for something that you probably understand well, and that was friction, right? It was pain, right? You had to have a DBA. If you have a relational database, you have to understand relational design. You have to learn all this stuff. NoSQL with schemaless, right? You could just make changes. You don't need a DBA. You're closer to the middle. That's certainly interesting, right? When you're looking at the friction of trying to deploy a stored procedure, go through that. So a little bit like we went through XML back in 2005, right? Remember when everything was in XML, right? In 2015, I feel like everything was NoSQL, and that's not terrible, right? Because it forced us on the relational side to look at some things. There are some things that SQL is not good at or not the best at, and we should definitely use it for different things. But you still need a DBA in 2015, right? And if you just don't want a DBA or you don't want to pay for it, life's a little bit harder for you. So what do y'all think about that so far, right? For you to go back, right? So you can see a lot of things have changed. There's been a lot of new stuff going on, but I bet if I looked at most of what you do, it's still very much like it was in 2005. And so now as we go forward and talk about some of this other stuff, the question you have to think about is that bad, right? I mean, it's bad if you're not using some great new function that would maybe make your life easier, right? There's a string split function now. You can do string aggregations and group by. You might be still doing that stuff the hard way, the old way, but it works, right? You could replace it or not. So if we go forward a little bit more, so now we've had more evolution, right? We've had 2016, 2017, and 2019, and now, unbelievably, SQL Server runs on Linux, right? Nobody in the SQL world would have believed that if you had told them that in 2015, right? Just, interestingly, even though it was originally from Sybase, which ran on Unix, right? It was just, it's Microsoft, it's Windows, that's how it is. And I think we had all grown comfortable with how hard clustering was, right? And just go, it's kind of what it is for, the super back office infrastructure and the things you have to have. So it runs on Linux. Service packs are gone, right? Service packs went away largely because people didn't want to upgrade until the first service pack came out, and that slowed adoption. And so Microsoft, I'm not speaking for them, of course, just stopped doing service packs to remove that speed bump, right? So now we get cumulative updates about every 45 days. So we patch more, right? We make more changes. Clustering is still hard, right? I mean, it's not that you can't do it, right? The wizard sort of gets you there, but it's still hard. Almost everything is virtualized, right? Except now we have containers and Kubernetes, which has kind of replaced virtualization as the buzzword, and also maybe as a thing that developer or DBAs look at it and go, yeah, not so much just yet, right? Because we're conservative, right? And there's some questions there. We'll talk about that. We've got Azure Data Studio. I don't know how many of you have tried that, right? It's a very interesting alternative to Management Studio. It's not full featured yet, but it looks like they have every intention of getting there on a modern platform, because Management Studio was built on top of Visual Studio, and that established a terrible tie to them back in the day because they couldn't upgrade Management Studio unless Visual Studio was upgraded, right? One of those great ideas on paper that just didn't work out. Yes.
Is it fair to say that Azure Data Studio is for query, like database developers, and management studio is for DBAs?
I think today that's exactly right. If you're a DBA, there's far too much missing out of Azure Data Studio to use it as your day in and day out tool. What I would hope is that it evolves where if you're a developer, you load the stuff that you want to use as a developer, and if you're a DBA, you load the stuff you need as a developer, and we get a first-class environment that iterates much faster than we have in the past. But there's no doubt there's a lot of logic and power built into Management Studio that is, it's not used all the time, and so it's not the first or second or third thing that we build, but it's absolutely worth trying. And I think it's one of those places, just like Power BI, where there's a rapid cycle. You see a lot of change there. Management Studio is updated, once or twice a year maybe. More often than it used to be, but still not very often. So you'll notice as I talked about this, I left out cloud, just to give you Azure guys a hard time, right? So, the cloud was talked about a little bit back in 2005, but nobody was going to put their database in the cloud in 2005. I say nobody, right? But it wasn't your first or second or thought. And even if you look at 2010, it was stuff like it was really tables and it wasn't really a SQL database. It was kind of a hack. A lot of mistakes, a lot of time to grow there. In the meantime, virtualization had to happen. I think it had to be a step in the road, both in terms of how the cloud worked and in terms of giving a business and the DBA comfort that was going to work for the thing that matters most, right? If you lose a web server, right? You rebuild it, maybe you're down for a couple hours. You lose a database server, that's a thing, right? So 2015, I think, is when the cloud started to become really viable if you were a SQL Server person, but probably not your go-to option, right? So let's change a little bit and look at this from some different angles. So the first is the server, right? If you think about how I see the world as a DBA, which is certainly going to be different than if you're a developer, right, or a CIO, I think I would say that DBAs almost prefer to be virtualized at this point. They don't want physical hardware. They don't want to, they don't want to build that, right? I think if you ask a DBA wants Management Studio and databases somewhere in the world, and to them that is the cloud. Right? They don't really care if it's in a VM or something else as long as they can fully manage it. But I think if you ask them, they would say, we absolutely want to virtualize everything. So then we start hearing about Docker to go along with the Kubernetes. So Docker is interesting to a DBA, right? Because it means that patching is faster and we can roll back from a bad patch faster. In truth, bad cumulative updates are pretty rare in our world. That stuff is pretty well tested. But if it goes wrong, trying to uninstall a service pack is painful. It's risky and it's usually not tested because we do it so much that it's just a lot of overhead where we go, we'll mitigate the risk, but we're not going to fully test it. So Docker is interesting to a developer, of course, because it means you have a better chance of running the whole stack on your laptop. Without junking up your laptop with a bunch of stuff that's going to go out of date. You go, oh, Docker, this is cool. Except you start to hit all these roadblocks with Docker, there's no Windows container for it. You have to domain join it if you want to use AD-auth, or you have to fight through, Kerberos authentication. Running, trying to really map your full dev stack locally, you end up hacking at a little bit. But for all that, you can make it work. And it's interesting, you can throw it away, you can change out a version. Lots of power there for a developer, especially when you start thinking about the idea for like webheads where you go, hey, instead of me giving you the bits, here's a Docker image, just deploy that, right? Well, that doesn't work for databases, right? Because for databases, we really have to separate the data from the bits. And Docker supports that. But what Docker doesn't do is go, hey, SQL, while you're running, we're going to snatch this out from under you and replace it with something else, right? So I feel like one of the friction points that we see in the world right now is, especially on the DevOps side, is everybody wants everything to be like this one perfect model. Data doesn't fit into that perfect model, right? And if you think about it, that is just as true if you're running MySQL or Oracle or DB2 or any relational store, right, where the integrity of that store is everything. And I would say to almost the same degree, any NoSQL store, right? You can't just snatch the engine out from under the data and expect to come back in the same place without an outage. And that's, of course, what we're about, is no outage, right? We want to be available when we have to be available. So a little bit long-winded there, but maybe then we get to Kubernetes. How many of you have looked at Kubernetes? Right? So Kubernetes is really interesting because it kind of takes containers and goes to the next level and says, I just want the behavior of a cluster without building a cluster. That's vastly oversimplified according to my friends who use Kubernetes, right? But it's really interesting because you can define it as code, as script, and you can just go, hey, I want this SQL Server cluster behavior from a Kubernetes cluster, and now Windows clusters can go away. Now we can run on Windows or Linux, assuming we have a Windows container, and we can just put nodes into a Kubernetes cluster, and now some things got simpler for us, got simpler for the infrastructure team, as long as you have somebody who fully understands Docker and Kubernetes. Those skills are hard to come by today, right? If I look down the road, I go, Docker, very interesting to me. Even if I can't patch a live server, you know, just the time it takes me to patch in general, sometimes when I do it right now on a live server, it'll take an hour to apply Windows updates. Right? So very, very interesting to me to say, here's a tested image that's patched. I'm going to take this node out of service, change the container, bring it back up. That's powerful, right? But that's certainly not the same as saying, hey, here's a new Docker image of what our product database looks like, deploy that, right? It doesn't take away all of the friction that you guys deal with all the time of going, hey, I need to add a column to this table, right? Docker doesn't solve any of that, right, today. I think very important to think about here is most people will adopt stuff that they can use, that they understand. DBAs aren't heavy consumers of Docker, and they're never going to be the Kubernetes guy, just like they shouldn't be the domain admin. So one of the things that slows this progression, I think more on the data side than anywhere else, is the people who have to deal with it day to day aren't going to have the skills to feel confident that when something goes wrong, they can engage and help, right? So that's a little bit about fear, right, to be honest, right? As we look at that and go, well, sure, if you guys can make it work on Linux and Kubernetes and Docker, that sounds great, but when it goes wrong, I'm just kind of watching, hoping you can put it all back together to the point where I can connect to SQL again, because until then, I'm on the bench, right? Kind of by design, right? I don't have enough time to be a Docker master and a Kubernetes master and everything else. I can learn something about it, certainly. I'm not saying we should know nothing, just like I should know something about Windows clustering. But if you think about the things that hold back adoption, both for DBAs, and for the CIOs to go, are we ready to take on the added weight of having this expertise, and are we going to give our team time to learn that, to grow comfortable with it, right? And can we do that in some split way? Can we do Docker in local environments but not in prod? Or does that mismatch just frustrate everybody? Why can't we just do it all the same way, right? We say that all the time, right? In the DevOps world, right? We're trying to make everything look the same. So then there's platform as a service. So how many of you like platform as a service? Right? So somebody give me an answer. Why do you like platform as a service? Scalable, easy to, yeah, low maintenance, right? Okay. Anybody not like platform as a service? How about Nick? Okay, you got to pay for it. It changes. It's OpEx now, right? So it's a different model. So why do you think DBAs don't like platform as a service?
It's not source control.
That's right. They don't have all the knobs, right? And so it's one thing to say, I've got a database server that's running in the back of Guido's Pizza, and to go, should I put that on platform as a service all day long, right? Because the workload is known. It's not going to change. Nobody's changing the database, and you go, that is perfect. I don't want to patch that. I don't want to worry about it. Oh, automated, intrusion detection, that's great. All those things are great. But if you do the work like I do here, where every 2 weeks we deploy changes to the database, and sometimes those are small changes, sometimes they're big changes, but where they have the ability to impact 5,000 concurrent users and maybe have a bad plan, you need full control. You need full control, especially if you do not have a superb load test. And I'm willing to bet none of you would want to raise your hand and go, I have a superb load test, right? Because that's the last thing we pay for. So for a DBA to say, oh, you can't run Profiler, you can't run extended events, you can't log in to the actual server and see what the file looks like on disk, that is a fear point, but a very real friction point to adoption, right? Now, if Platform as a Service was exactly the same amount of management, if I could manage it the same way, my objections, my concerns would go down, right, for sure. But I like what Esteban said, right? It's the scalability. It's perceived to be kind of instantly scalable, right? Except a lot of time it's really not that easy, right? Because if you just need more CPUs, I mean, we've kind of had that since the VMware days, right? You could just provision more CPUs. But a lot of times you hit these architectural bottlenecks, right? Where you go, I've put everything in one database, but that database is just getting big, and just the laws of big mean that I would do better if I split that guy up, right? If I did some of my own partitioning instead of going, I want a magic system, right? Hyperscale, Azure guys, anybody running Hyperscale? The DB, right? So that's designed to be the mega scale, right? Does a lot of magic behind, like crazy magic behind the scenes that's still built on top of SQL Server, but allows almost unlimited scale out, but it's a trick, right? You're offloading stuff, you're just getting them to do the work through an abstraction layer, and as long as that works, that's great. When it doesn't work, right, it's going to be a little ugly, and you go, well, how hard is it to just figure out some of that for myself? Anybody ever do something where you connect, you look up a customer in a catalog, and you go, based on that, I'm going to go to server X and be in database Y? You guys have probably built that, right? Right, where you need to partition by customer, you know, or maybe by geography. You want to do some of that stuff? Sorry, I didn't set the timeout. Oh, that's really bad. Come on, there we go. Sorry. So, no. So Platform as a Service is one of those things that if you have a DBA, they're not going to be maybe excited about adopting it. Doesn't mean you shouldn't adopt it, right? Remember, I'm not here to say everything I think is right and everything you think is wrong, right? That's not fair or even close to accurate, right? But you have to think about both sides and go, have I trained the team? Do I have somebody who understands this? Am I willing to live with the trade-offs that come with it to get the advantages out there, right? And there's times when it's a perfectly good decision. So the thing that you look at today, though, hardware is still a challenge, but maybe in different ways, right? One of the biggest ones that I think Azure has addressed some and maybe less so AWS is that the ratio of CPUs to memory is not great for database work, right? You know, you'll get an 8-core, you know, server with, you know, like, you know, 64 gigs of RAM, and I go, that's useless. It's a SQL Server is ultimately this huge caching thing, right? We make money by loading everything into memory and keeping it there and keeping it exactly correct. So we need memory. Memory is the lubricant that makes it all work. So if I want to go in and get 128 gigs of memory in Amazon, because I work in Amazon these days, I have to go from 8 cores to 16. I have to double my server cost, right? So that's one of those things that's held up adoption is the actual cost. Because when you look at what you pay for database servers, it's far, far higher than what you pay for anything else. I mean, you should go look at the numbers. And you know, when you start talking about a primary and a couple copies, it's big dollars, right? Big dollars, which doesn't mean you shouldn't do it, you shouldn't spend it, but it also means that the business is going to go, well, can we not get the 16-core server? Now we're back to where we were in 2005 to go, hey, we have to optimize because we don't want to buy more stuff, right? It hasn't gotten that cheap. It's not the storage, right? Storage is cheap, right, in most cases, except come to find out all the cheap storage is over the network storage. And that was never a good idea, right, for a database guy. I mean, you can make it work, right? And as long as you're not going to disk, life is good, but as soon as you go to disk, the latency kills you. I don't care what you're running over, the latency kills you. And that's why you see so many people running on NVMe locally, because it's like 240,000 IOPS, and that hides a lot of bad queries, right? It does, right? Sometimes stuff where you go, yeah, I could spend a bunch of hours optimizing, but I can just do this and make the pain go away. That's not dumb, that's not bad. And so, in particular, what we can't do is scale up and down based on load, even on the platform and services aside, right? What we would really like to do is to say, you know, Monday at 8 a.m. I need 16 cores, and Monday night at midnight I want to go down to 2, right? I want to stop spending all that very expensive money, right? But we can't, right? There is no good way to adjust that right now in, I won't even say real time, but on any kind of scheduled basis, right? The tools aren't there yet, right? The response time is not there. You know, the stuff that we do in Amazon, when we scale up, you know, it's 5 to 10 minutes for a server to come online. If I need the power now, I can get it in 10 minutes, but I can't get it now, right? So I'm back to that little bit of over provisioning, spending some money I don't need to. All those things go into that. So all that is really a long-winded way to get you to think about the reasons that you get pushback, right, when you want to do stuff. And it doesn't mean you have to give in, right, but you have to think about it and go, do I really understand the costs? Do I really get all the savings that I think? What are the things that I care about most, right? Because there's lots of little hidden things. So like, I have it on a slide later on, but I'll talk about it now. So for example, SQL Server, you know, we get these releases basically every 2 years, but everything goes cloud first. It's just feature flagged for the things that only apply to a physical install, which means you get bug fixes faster. It also means in some cases you're the guinea pig, right? Because somebody goes out there and says, turn on this feature flag for 5% of the users, and you know you're one of those 5%. You're the beta tester, right? And you're not opting into that, right? Does it matter often? Probably not. Does it matter sometimes? It probably does, right? Because when something goes wrong on the infrastructure side, I guarantee you the first question we're going to ask is, what changed? We're going to ask that question over and over, what changed? It's incredibly frustrating to realize that nothing changed, but something did. All right, so upgrades. Here's another piece, right? So if you built that app back in 2005 and it's still running on SQL 2005, you know, you're out of support, you're not at all within compliance for anybody, unless, I don't think you can even buy an extended support contract on that now. But the truth is it would still run just fine, it's just a security risk, right? What's interesting is in the space of a couple hours, depending on how much testing you want, is you could upgrade that guy to 2019. Right? One of the things Microsoft's learned from moving to the cloud is that deprecating features is a bad idea because that breaks people, right? They can't just roll out those upgrades. So they will largely mark something as deprecated and say, we'd rather you didn't use this, but we're not going to turn it off. Right? We're not going to turn it off. So that cloud first thing kind of cuts both ways when we think about how that works. But I want you to think about the upgrade, right? Because upgrades are scary for a lot of people, right? But you could literally take, you know, go back to 2005, 2008, take a database, run the install wizard, it will upgrade it, and you can set the compatibility level back to what you were on and get, I won't say guaranteed, but almost absolutely the same query design, plan design that you had way back when. That's your fail-safe, because you don't care about the bytes on disk and the integrity. You're kind of confident. You're going, what if my query plans change and everything goes bad, right? You can be pretty comfortable with this because not only do you have the compatibility level, but you've got query store. So how many of you have ever looked at query store? So query store is one of those DBA things, right? Where you go, I've got a query that's gone bad, the plan is bad, and I need to make it look like this. Query store, you can basically go in and see the plans that have been used and go, oh, that one was good. Push the button and it will use that plan. You don't have to learn plan guides. Now, that's not to say it's magic. You have to figure out the right query plan, but you can pretty easily force it to behave in a way that maybe it doesn't think is the right way. It's very easy to override. It also means you can run query store before the upgrade to capture some history and see what your plans were And then when you upgrade, you go, oh, look, here's a plan regression. I'll just go back to the previous plan. Those are all things where if you want to hire top-notch people, if you want to keep your DBA, you can't be running on SQL 2005. Even though it works just fine, right? You have to upgrade. So you have to go back and take a fair assessment and go, is it really that dangerous? Why am I holding back on upgrading? Why aren't I saying I'm going to upgrade 3 months after release, right? Because I know it's been in the cloud for a year before that. Why do I need to wait 2 more years before I upgrade? What am I waiting on to do that? All right, so then DevOps, maybe closer to you guys. Y'all doing all right? I feel like I should have just wrote some queries or something. Yeah, would that have been more fun?
So say that 2019 has compatibility mode for 2005, let's say, but that includes the data types that are going away?
Yes.
Okay.
Yeah, no, it all works. Like we've moved to varchar max, and in varchar max, text is still supported, right? So I'm not saying you might never hit an edge case and you shouldn't test, but I would tell you that I would be very, very comfortable walking in going, let's run the upgrade on a copy and take a look at it. If it's clean, we should just go, and you're going to be in a much better place running on SQL 2019. Right? So let's talk about DevOps. Any of you here doing DevOps? I know that means many things to many people, and it sounds cool, so you should all just raise your hand. And source control. So I didn't put this in the earlier slide because I want to talk about it here. If you went back to 2005 and said, how many people have their database in source control? I'm thinking that was a pretty low number. I mean, that was 5% or something. And I remember doing it. It was basically, we would script out the database and just check that in once in a while, right? We had a snapshot. We could go back and look at it, but we also had a bunch of backups. We could go back and look at that. So the world has changed a lot around that. Those two topics. So I think if we start with, to me, the heart of DevOps is the idea that infrastructure is code, right? That I can really describe in metadata, this is what my infrastructure looks like, and I can just tear it all down and build it up again and know that this is exactly how it looks like. That works great for web and many other things. Doesn't work so well for DB servers, right? Because you can't destroy them. Right? You don't want to take the outage. So this is a place where, in the DevOps language, we still treat our DB servers like pets. Maybe Docker Kubernetes fixes that 2 to 10 years out, right? I think that gets us closer. Because for us, right, we would like that too, because we hate doing in-place upgrades because we end up with all that cruft on there that we don't want. But yet at the same time, building a new cluster all the time, you're like, I just don't want to do that. Right? And most of the tools, when it comes to building a cluster, not an individual machine, or building an availability group, you go, wait, chef, wait, it doesn't quite want to do this, right? Or I have to kind of work around it to get there. So we have that problem. We've got most of our DBs into source control. I bet it's 70, 80%, just guessing. I think if somebody's out there running a legacy app that works fine, it may not be in source control, but I would bet anybody that's doing active work has at least gotten it into source control in some fashion, even if they haven't built that whole pipeline down to the DB level, right? Because that's usually the last piece that really gets solved somewhat cleanly. As I look at 2020, one of those friction points that I always look for is the handoff from devs to DBAs. Right? You guys build something cool, and then one of the Azure guys, you're like, hey, here, do this. That's a friction point. How do we describe that, right? How do we have that perfect pipeline, or should we have the perfect pipeline? We've had the argument here a little bit because they think they should just run these scripts and go, and I'm like, well, no, maybe not so much, right? Because, sometimes you're doing a simple alter on a table, and you look at it and go, well, here, just run this. And I go, except, it's a billion row table, and I need to run that while everybody's using the table, so I can't do that right now, right? That's those friction points where we go, these changes just aren't instant or simple if I'm not taking an outage. And I think a big part of DevOps is to not take the outage. Even though they don't have to be synonymous, if you think about it, there's nothing that says you can't have infrastructure as code and a pipeline and do all that stuff and still take your monthly outage and do all that stuff, but in a lot of cases, our goal is to get to the point where we do not have to wait for that. Right? So still a big friction point about what should be handed off, how should that handoff be orchestrated from a compliance perspective, security, and just a plain, the realities of life. How do I handle this when you're wanting to make a change to a database that may take 30 minutes? How am I going to do that? So another thing I think is really hard at this point of where we're at is having the expertise on the team to understand DB changes. Right? Because I think it's one thing to say as a developer, I expect you to write stored procedures. I think that's a fair ask. I think it's very hard to say, no, wait for me to write it, right? Because you got to write the query anyway. You should learn that. I'm not asking you to be a SQL Server master or a MySQL master, but to go, you should be able to do the basics of designing a table and doing that. And then we can fine tune it together, right? But I think a lot of DevOps thinks that you're going to have that DBA resource on the team. Well, now we're back to 2005 where we don't want to hire a DBA because they're expensive. Nobody wants to put a DBA on every dev team, right? Because it's expensive. So that's another place that I think is slowing the adoption a little bit as we try to figure out how do we empower teams to do database development work, not constrain them, but then still get them the expertise to go, well, maybe we should do this way, or that's not a best practice in this case, or here's a different way. How do we get that expertise back and forth? That is a real holdup because we see these teams that do stuff and then they go, here, do this, and you look at it and go, that's problematic, right? Now we have to worry about changes. We have to worry about backward compatibility, right? Backward compatibility is a huge thing for us when we're deploying database changes. Only a couple more, I promise. So I talked about, I think, most of this earlier, skipped ahead a little bit. But I think when you think about how DBAs see the cloud, right? We don't care if it's a DBA in the server, a VM in the server closet, or a VM in Azure or AWS, whatever. We can connect to it with Management Studio, and we don't care. And somebody else is managing all the rest of the stuff, and we really like that, right? Because you want to leave, we specialize in infrastructure, right? You want a VMware expert, or you want a storage expert, or a security that's making those changes. We don't want to try to master everything. And as soon as you get into that delineation of roles, it certainly, you start to go, wait, I don't want my DBA changing enterprise storage, changing enterprise security policies. So as long as it's in a VM somewhere and you want to put it in Azure, we're totally good with that, right? There's a lot of advantages for us, decreases our risk in a lot of ways. Then, though, if you start about moving to platform as a service, now you're asking us to specialize, right? Because what it looks like in Google is not going to be what it looks like in Amazon and not what it looks like in Azure. And so that is a friction point for us, probably for you guys too in some cases, right? Because like here, we're an Amazon shop. So, if we're going to use, Redshift or Aurora or something like that, I have to learn those skills. That's okay. Those don't help me when the next job is an Azure shop, right? Doesn't mean we shouldn't do it or that I shouldn't learn it, but they're not portable skills, right? So what's interesting is, for the most part, SQL Server, without regard to how it's hosted, looks almost exactly the same in Google, in Amazon, in Azure, except Azure is the only one that has Hyperscale where you can really scale up, and they're the only one that has a real platform as a service offering, right? AWS has RDS, right? It's a managed thing, right? Where they do stuff behind the scenes and, it's availability groups or DB mirroring or whatever. So this is hard for us, right? Because we're trying to figure out what should we learn, and the best world for me is that SQL Server is running someplace and I really don't care as long as I can fully manage it, and you have the ability to change the CPU and memory and IO to meet the demands of the application. That makes sense, right? It's one of those things where the reality and the practice, they work in some cases, but not all of them at all. What to learn here, I think, is really the tough question if you're a DBA. Right? In today's world, if you're a SQL Server DBA, trying to stay focused on that world, you go, well, I've grown up essentially in a Windows world, right? Windows clustering, Windows, all that. Clearly, I need to learn something in Linux, because if you ask anybody on the infrastructure side the choice of Linux or Windows, they're going to say Linux, right? Right? It's faster to patch, it's faster to deploy, tends to have less problems. And I don't care, other than I don't know much about Linux, right? Maybe I can boot it up and log in and do whatever, right? But I don't have that comfort level. So you look at that and go, well, I've got to learn that, but what about Kubernetes, Docker, all these things? How much of that do I need to learn? Where should I focus the time I have, when I'm not doing my day job, right? So it's really interesting, I think, to be a SQL Server DBA, looking at the world going, this could really go either way. This could be great, where SQL Server just runs everywhere, and I'm like, I don't care what you guys are running. That's my stuff. I can connect to it. I could manage it. Or we could see that splinter, right? And really become very, very much different offerings, because I guarantee you that Amazon, if they have big dreams in their head, I'm certain they do, it would be how to get the SQL Server customers as their customers, right? Not running SQL Server VMs, but to stop sending that money back to Microsoft, right? To go, hey, you guys come over to Aurora, this is cool, it'll scale. And heck, I don't know, I'm not an Aurora guy, maybe it will, right? But it's certainly not a painless change. So really interesting for that, right? If you're an Azure guy, then you're just going to go, well, I'm staying in Azure, right? I'm never going to go work for those other guys, hopefully, maybe, unless they offer you a lot of money, right? So, and then there's the, outside of that, then there's the NoSQL stuff, right? We'll talk a little bit, we'll talk more on the next slide, but just think about from a learning perspective. If we start to use Cosmos DB or Redis or Elasticsearch, are we prepared to hire someone to manage that? Or do we think it doesn't need to be managed? Right? Because we should think about that and go, we're using this new technology stack. Who is going to manage this? Who's going to own to make sure that we're not spending too much money, that we're secure, that we're doing all those things, even though we don't have to patch and install it anymore? Who is going to own that? Should I learn that? I learned some about Redis this year. I had a great time.
Are there NoSQL DBAs? Is that a big thing?
I don't think that's a thing.
Who takes care of that?
That's a fair question.
What's the question?
Are there NoSQL DBAs? Sarcasm aside, I'm sure there are, right? If you have a big install, I'm sure that there are people out there, especially Elasticsearch, right? It has some complexity. Redis, I don't know, probably not, Cos.
Developers taking care of that, or the admins, or
I think that falls back in the admins, where I think that the hope is if you've lowered the cost of administration enough that you can add that to somebody's portfolio. The problem I've seen, stealing hopefully off another slide here, is that nobody gets data like a data guy, right? Data guys care about data quality, about performance and all that. I looked at an example recently in Redis where they were storing an int, right? Of course, in Redis, everything is a string. That's okay, right? That's how Redis works. That's not bad. But the way it was serialized, an int would take 54 bytes. Even as a string, it should be 10, right? 10 characters in a billion, right? 54 bytes. And you go, is it cheap? Can I afford it? Sure. But when you talk about, do I need to scale? What am I paying for? You go, wait, I'm throwing away 44 bytes per int. Only a data guy, data person, is going to see that. Your network admin, your Windows, Linux admin, they're not going to drill into it. They're going to go, is it working? Is it patched? Whatever, change the config, and that's good. And then on the other side, the developers are making it work, and that's good. So often the DBA, that owner, is the person who kind of reconciles all that and goes, are we in a good state? Are we cleaning up? Are we removing deprecated columns? Are we storing data efficiently? Can we do some compression? Are we removing old data? If you don't have that person there to manage the data, it will go a long time, maybe forever, but I promise you, eventually, it'll hurt you, right? Trade-offs. Not saying you have to, but you think, why am I not going to do that? So my favorite use of NoSQL is caching, for sure, right? I mean, SQL Server, we do a tremendous amount of caching, and I probably am bending the value of that word a little bit, right? But in SQL, our goal is to do everything in memory, right? We still commit everything to a log file. We've still got 100% recoverability, but our goal is not to be going to disk, because disk is slow. Even if it's NVMe, I don't want to go to disk. I want to cache up, right? It's why one of those old myths that I didn't put on my myth slide is that SQL Server is leaking memory because it starts up and you just see the graph go up like this until it hits the top. That is by design. We're going to load up every bit of data we can and try to never go back to disk to read from it. So Redis, I like for caching. I'm sure, there's Memcache, there's a lot of options out there. Redis is really interesting to see somebody reimagine a particular slice of data access and see how it works. When you look at the response time for looking something up, it's 01. It's the same regardless of size. So I watched something recently where the number of requests per day went from something like 1 million to 2 million. I mean, it was like a crazy doubling, and the CPU usage basically didn't change. I mean, not to any measurable thing, right? It just totally absorbed it. I was like, that's crazy good. I wish SQL Server could absorb that kind, right? If you double my workload, I'm gonna feel that, right? We have to check on some things. Redis, it's like, no, just perfect. I was like, that's great. But of course, if you're gonna cache, then developers, how many of you are good at invalidating cache? Or have made a mistake about invalidating cache, right? So caching is no free lunch, right? But I would just tell you, I think DBAs don't think enough about what you should cache, and I think you probably don't think enough about what you should cache, right? Because when you think about that cost thing, right, you got this big rock, this big expensive thing in the back that you got to pay for. I've seen cases where you could offload 3 or 4 million queries a day to offload some data that was immutable, that was never going to change, but we were just looking it up over and over and over and over and over again. Never going to change. Why wouldn't we cache that, right? So both sides have to get better at that, right? We have to look at that and go, immutable data is an easy kill, right? We should look for that. It goes, is there anything immutable? Lookup lists, is the list of states ever going to get smaller, right? Cache that up, put a TTL of a year or something, right? And you just know, yeah, if we we kick Hawaii out or something, we'll go figure that out. I'm not picking on Hawaii, I've never been there. So then we get to the next part though, which is what's the source of truth? This, I think, is the place of confusion in our business. So often we have that phrase, single source of truth, which I think is really confusing. Because single source of truth, when we say that, I think people think that they mean that I want to be king and that everything should be in SQL Server. And I don't think that. I think you can have 50% of your truth in Salesforce if you want. But that is the truth for that 50% of the data. So if you're going to load something into Redis or Elasticsearch and you're going to treat that as truth, you better be good, right? You have to be good at cache validation. You have to be good at getting the entries in there because it has to work. Think about how indexes work in SQL Server. When you query an index in SQL Server, if that index was behind the changes to the table and we ran a query using the index, you would not get the right answers back. You'd get them back fast, but you wouldn't get the right answers, right? So this is the thing that I see that I worry about is to go, if you're going to take data from any store and put it someplace else, you better be good at that. And you better have a way to check and make sure that it's correct. Because I promise you what will happen is they're going to go, hey, are we sure this is in Elasticsearch? Are we sure this is cached? Are we sure this is the right value? How do we figure that out? Especially if we haven't modeled it one-to-one. And of course, nobody would, right? Why would you model SQL Server tables in Redis? I mean, that's round peg in a square hole, right? So you're going to flatten it out into a hash set or just take some portion of it, maybe not even use the keys, or maybe you're going to consolidate a view and store that. If you're going to use NoSQL as a copy of truth, you got to be on your game. Now, you're probably thinking though, well, hey, wait, that's easy. I'll just make it the source of truth for that stuff, right? And for some stuff you can, as long as it's standalone, right? But as soon as you go, well, half my answer is over here and half my answer is over here, and if it was all in a database, I would just do a join and get the answer like crazy fast. But now I'm going to go get everything from over here and everything from over here, and I'm going to essentially write my own join. You haven't necessarily made the world a better place. So you have to really understand, can I really take this and move over here? I worked with a great example last year. There was a large log table, and they were going, and everybody's like, a log? Well, that should be in Kafka, or that should be something else, or blah, blah, blah. If it was just a log, sure. Except the problem is when you went to let people look at the log, you had to join to a bunch of tables to understand what all the IDs meant, and you had to apply security to it. So you couldn't just put the log over there in Kafka. You were now going to have to copy all this other stuff over there, or else you might query back 10 million rows to send to me to go, of these 10 million, which 500 can I look at? So that's where I think the confusion is, right? Is I would like to think that every SQL DBA out there says it does not all have to be in SQL, but as a data guy, I'm asking, what is the source of truth for this data, and can you validate that, right? That's where we have to meet and just try to figure out, because I think absolutely the future is we have to decide where's the right place to store this data, right? Where's the right place, how to store that. Oh, almost out of time. So another question I would ask when we talk about not just NoSQL, but kind of split data stores, split sources of truth, is how are we going to do the reporting? Now, I think the textbook answer is a data warehouse. And that's fine. If you have the resources to build that and pull everything in, that is the textbook, I would even say the right way to solve that. But for a lot of businesses, those are high failure rate projects. They're big investments. I wish I was a BI guy. I swear that's where you get like 2-year contracts over there to build some mammoth thing. It's not like a 5-day engagement to make some queries faster. So how do we do that cross data store reporting, right? So just like if you're going to bring in a new technology and tell the CIO, hey, you should use Redis, you should be saying who's going to manage it, but you should also talk to them about what are your reporting needs, what are your security needs, because like Redis, there is no security model. Right? It's basically, if you get to Redis, you can look at everything, and so now it's 100% on the developer. And then you go, well, do I have the competency in writing tests to make sure that I'm proving that? Am I really ready to take all that on? Because it's not as easy as going, Redis is super fast, right? It adds all these downstream things. So finally on this, here's my last challenge to get you to think about. I think there's absolutely a place in the world for specialized data engines. If you're doing graph work, there's nothing better than a graph DB. If you're doing time series work, there's nothing better than a time series DB. If that's where you live, right? But if it's a small part of what you live, then I think you have to really think about it and go, I need to store some graph-like relationships. And maybe that doesn't work like a super cool or super fast without some tricks in SQL Server, but is it really worth spinning up another data store that I now have to figure out someone to manage it? Is it the source of truth, or is it a copy of truth? Is it worth all of that to solve this one thing that it's really good at? And it might be, right? I think more often it's not, right? You have to get to that tipping point. But that's the thing I would tell you as developers, right? Is when you're adding technology, you're adding complexity. And you don't want to try to make SQL Server do everything. There's things it's not great at, right? We get that. There's things where it's okay at, right? Like full text search is a great example. I wouldn't hold out full text search in SQL Server as the solution for searching, but if you just need kind of a basic search, looking through documents, finding phrases and stuff, it's perfectly serviceable. As you scale up, it doesn't scale up, I would say, with it as cleanly as you want, what you want, and it certainly adds complexity to the database. It's one of those things I'm quite happy to say, search, oh yeah, you should put that in Elasticsearch. That's great, good luck with that. Right? Take that off. Let me be relational. Let me do speed and security and all those things and move that to a specialized tool. But there's nothing wrong with starting out with full text search until you get to that tipping point of having the need and the time and the money and the expertise to make that leap. Because most of the time, cynically I would say, we go far too early and we don't do it well, and now we're stuck with it. All right, so real quick, I wanted to take you back to the 2005 and think about myths, right? Remember when I was starting out, I said I want to challenge you a little bit to go back and revisit. And one of the things I would say to do that is, read through the release notes for the different versions of SQL Server. Look at what's changed. And again, I'm not expecting you to memorize it, and you can filter out all the DBA stuff. I mean, that's fine. Not asking or expecting any developer to be a DBA, but kind of look through that. But storage is cheap is my favorite myth. Storage is not cheap, right? I guarantee you, if you're storing a bunch of stuff in S3 or whatever the Azure equivalent is, at some point somebody's going to go, can we tier that? Can we move some of that to cold storage? Because why not? You can save money. So apparently, even though it's cheap, it's not cheap enough, right? It's not free. SQL Server shouldn't need a lot of memory. I swear this is always said by developers. I don't understand this. I mean, it is the lubricant, right? That's not to say every server needs a terabyte, but you know, if you're hitting disk, it's either because you have bad queries or you just are more active than you can sustain on that 32 gigs of memory, you know, like the thumb drive I have in my pocket, right? You go, there's nothing wrong with putting a couple hundred gigs of RAM in your average small to medium server, right? You want to keep the CPU count down. Here's one. How many of you think stored procedures are hard to write? Hey, that's pretty good. I think somebody must have told you not to say yes to that or something, right? They are a little bit hard to test, right? I mean, depending on how you approach testing. There's TSQL, which I'm learning this year, trying to learn some stuff about to do that. But certainly you can write unit tests for it. What about foreign keys? Do you guys like foreign keys? Right? Foreign keys are complicated, right? You got to draw these lines, right? But remember, it's a relational database. And when we say relational, that really has meaning. We forget how it means we have to relate things. And those lines, those foreign keys, are how we do that. So you can make the argument that you don't need foreign keys because you do such rock solid testing that you'll never make a mistake. Nobody's that good. You're only as good as your newest developer who doesn't understand that when you delete from this table, you also have to delete from that table. Foreign keys keep you safe. They add a tiny bit of overhead, but they actually help the optimizer too, because the optimizer can do things like if you write a left join, there's a foreign key, it'll coerce it to an inner join. It goes, no, it's an inner join. It has to be there, right? It can do a lot of smart stuff for you. So I think a lot of this goes whether you even like the relational model, right? But a talk for a different day. Transactions always roll back if something goes wrong. I bet you all think that, right? But not every error causes a transaction to roll back. Not every error causes a transaction in SQL Server to roll back. It's a terrible design in my view. I wish it wasn't that way, but we're stuck with 25 years of it. So you can do an example where you insert into a table, it fails because the string was too long, it was truncated, and then the next line does the delete and then it commits the transaction. That can absolutely happen in SQL Server unless you set exact abort on. And then my last one there, round trips don't matter. How many of you think round trips don't matter? And when I say round trip, I mean the web server calling the database, web server calling database. How many of you think the round trips don't matter? Come on, somebody. Santosh looks like one of those conspiracy guys who thinks they don't matter, right? They add up. They add up, right? Doing stuff in batches, reducing your lock time, adds up. Even though I get that, the signal goes at the speed of light, and how long could that take? It takes longer than the speed of light. All right, I'm getting the signal back there that I'm out of time. So this is my LinkedIn information. So if you've got questions, just want to connect, I'd love to hear from you. So what I'm hoping tonight is I get you thinking a little bit about how does a DBA see the world? And hopefully it wasn't all my way is right, but also get you thinking about, in terms of philosophy, what is your philosophy about a platform? Because SQL Server is a platform. I'd say JavaScript is a platform, Redis, all those things. When you use any of those things, you can make a decision about, do I want to use it naively, or do I want to use it to the max, or somewhere in between? And I think we're really good about thinking about how we do JavaScript and how we do CSS and all those things. And it feels like, though, we kind of hit this mental block when we get to SQL Server and go, why aren't we thinking about that as a platform? Which doesn't mean we have to use everything on there, but to go, there are some things there that are good for us. We should use those. And when I say SQL Server, I really mean a relational platform. So I hope you all had a good time tonight. I think I'm going to give the mic back to Santosh now, but if you've got questions, I'll be around for a while. I'd love to talk.